So to name simple ionic formulas, we're going to work with ions. Those are charged particles. Either they're positive or they're negative. Now, the positive is called a cation. I don't care what it looks like. It's called a cation. Please don't embarrass yourself by going to college and call it a cation or something. This is an anion, not an onion or an anion. Again, don't embarrass yourself. I promise I'm not lying to you. So there are charges at the top of a lot of your columns on your periodic table. Go look. The first column is +1. So things like sodium and potassium are charged +1. Hit pause and go look. And there are 6 columns that I put charges on top of. If the anion is a group, you can find it on your ion chart, and that's on the back of your periodic table. Hit pause and go find that. You can find the name, the formula, and the charge. The charges must add up to 0. That was the point of our game. So we often need multiples of one side or both. If the anion, that's the negative, is just one type of element like Cl or Br2, notice you can have 1 or 2 or 3 or 4 or whatever, but if it's just the one type, without any extra oxygens or anything, then the ending is just whatever ide, like chloride or bromide. See numbers 1 through 4, which we will do. There are also 2 exceptions, hydroxide and cyanide, and those are on your ion chart. Sorry, it seems like there has to be an exception to so many things. I didn't name them, go blame someone else. Except for those 2 though, ide means it's just that type of element, like chloride means it's just Cls, and bromide means it's just Brs. They are groups, but use the ide. Those are groups, but they do use the ide ending. Sorry, they're on the ion chart. So let's name the following ionic compounds. So what we do is for the cation, we just put the name. So Na is sodium. You can find that on the periodic table. So sodium. And then if it's just Brs, we said it's bromide. We would have the ide ending, so bromide. We're going to start off simple here. Ca is calcium, so calcium. And that's oxygen, so just oxide, because it's just oxygen. That's lithium, and again, for the cations, we just put the name. It does get a little bit more complicated in a moment, but for right now, on the simple ones, it's just lithium. But there are 2 of them, I know, but we don't need to get into that. You can just put the cation name for now, and we'll give you the exceptions in a bit. And that's sulfur, just sulfur. No extra nitrogens or oxygens or anything, so it's just sulfide. And here's magnesium, Mg. And that's bromine again. And it's still bromide, even though there are 2 of them. And we will get to that. Why that? That's because bromine, if you look on your periodic table, is always -1. Go look. So when we say bromide, they should be saying, oh, it's just bromines. Somebody reads bromide, so they should be saying, it's just bromines. And then they can work out how many it is on their own, because we know it's -1 because they have a periodic table, don't they? They should. And this is beryllium. I think I spelled that right. And that's hydroxide, and that is our exception. Remember talked about the exceptions, and I said C number 5. So we're just going to put hydroxide though, because they should have some sort of an ion chart so that we can say hydroxide, and they know what it is, and they know it's -1. So we don't have to tell them it's -1, because it's always -1. If you look on your ion chart, there's not another kind of hydroxide. So let's try it the other way. Let's write the formulas. So potassium, look on your periodic table, is K, go left, go look left. It's +1, it's in the I'm always +1 column. Iodide tells me there are just iodines, and look, it's in the -1 column. You may have a periodic table that just looks like it says 1. That's supposed to say -1. Notice it says -3, -2, and then it's supposed to say -1. The next to last column to the right is -1. If your periodic table does not quite seem to say that, then I would pull it out of the sleeve and write -1 above F. Magnesium oxide. Magnesium is in the +2 column, and oxide is in the -2 column. Now, I did kind of forget something here. I know I'm done because these charges add to 0. I know I'm done here because these charges add to 0. The point is to make the charges add to 0 when you're writing the formulas. And they don't always add up automatically, like on number 8. So go find aluminum. It's a +3. Look at your periodic table. And chloride is a -1, which means that this does not automatically add up to 0. We're going to have to fix it. But you can have more than one of these. And what would you need? You'd need 3 total here, wouldn't you? 3 total of the -1s so that it balances out the +3. And then we have +3. And then we have -1, -1, -1. Notice that we're putting the total here, not the additional. I've had some kids say, oh, 2 more, and write a 2. We're writing the total number so that this is -1, -1, -1 to balance out a +3. Turn your periodic table over, and we can find nitrate. Now, you probably remember Na is +1 because we talked about that. On 9, find sodium, look left. It's Na, it's in the +1 column. And now, when you see stuff like 8 and ite, you're going to need the back, you're going to need the ion chart. So turn it over. And we know since it's on the right side, it's the negative side. So this will be a negative. And it'll be under the word anions, because remember the anions are the negatives. And it's alphabetical, so look under N. And it turns out NO3, it's NO3 -1. Then I have a lot of kids say, no, it's -3. Okay, let me try to be clear about this. It's NO3, and that whole thing is -1. So this does add up to 0 already. It's already fixed, quit fixing it. +1 and -1 already adds to 0. You're done. So this is going to involve some chart flipping, I admit. You're going to turn this over a lot. So make some room or something. Calcium on the left side of your periodic table is Ca +2. And then turn it over, because I said 8s and ites and stuff are on the back. Carbonate is CO3 -2. The charges need to add to 0, but they already do. So you're done. Now, I will point out, for all you kids headed to a college class someday, officially in these formulas, these charges are not here in your ionic compounds. I'm going to look past it. It's a lot of erasing. It's a lot of hassle. I'm not going to make a big deal about it. But I imagine a lot of college classes would consider this really bad form and even like -1 out of 4 points or something for leaving those in. Officially, the answers are like this without the charges left in. So I did warn you. Lithium is on the left side, it's a +1. On the back, sulfate is SO4. It's a total of -2. Now that does not add to 0 yet. We're going to need 2 of the +1s so that we have +1, +1, and then a -2. And that adds to 0. Beryllium on the left side is a +2. And phosphide, remember ide? IDE means only phosphorus. Go look at phosphorus on the periodic table. It's in the -3 column. And that most definitely does not add up to 0. So let's make a visual representation of +2 and -3, like here. I need them to even out. I need them to sort of balance each other out, sort of. I need them to add to 0 more specifically. Well, I can only use them in these blocks because that's the way they are currently provided to me with the things I am using in nature. +2 and -3, so I can have another, let's make this more even, huh? Another +2 thing. And then I could have another -3 thing, but a -3 is going to take me out like here, huh? And so to make them even out and add to 0, what I'm going to have to do is get another +2. And it's going to take 3 of these and 2 of those. And then I have +6 and -6, and that adds to 0. So I'm going to need 3 of the +2 thing and 2 of the -3 thing. Magnesium hydroxide, well, magnesium is on the left, it's a +2. Hydroxide, remember, is on the back side on the ion chart. I don't expect you to know that yet, to remember what it is, but it comes up a lot, so eventually you kind of will. And that's a minus, and that does not add up to 0, so we could make 2 of them, though, and that would add up to 0. Oh, right. So also, if you have a group, and you need more than one of them, we need to sort of box them in with parentheses and put the counting number of the group, the number that you want to have, outside the parentheses. So this is 2 sets of hydroxide. It's 2 sets of the thing that is -1. So now I have +2 and -1 twice. Then the kids who are extra double paying attention said, wait, does the minus go inside or outside the parentheses? To which the answer is, remember when I said they're not really there? Those charges are just our little bookkeeping, and they're not really there. So the answer is we sort of shouldn't have put them in the first place. So they don't go in or out. They're not there. Look at the more official answer. The plus and minus charges aren't really in the answer. That was just us writing stuff down so we wouldn't forget. Sodium is on the left side. It's in your +1 column. Phosphate, go flip it over. Hit pause, go flip it over. Is PO4 minus 3, and it is not minus 12. This 4 does not multiply that. It's PO4. This whole thing is minus 3. But we have a +1 and a -3, and that does not add to 0. We're going to need 3 of that. So that we have +1, +1, +1, and -3. Well, let's try this. Start with an easy one, sodium and chlorine. Sodium is Na, look at the left. You'll soon remember that it's over there. It's a +1. We're going to do the formula. Chlorine, look to the right. It's in the -1. The charges have to add to 0, but they already do. So quit fixing it. It's already fixed. That's the formula. And if you want, you can erase the plus and minus if you want to be superficial about it. So what's the name? We just put sodium because the name of the cation, the positive, just remains as it is, sodium. And then we said, if it's just chlorines or something, just chlorines, there's no extra oxygens or sulfurs or anything, then it's chloride. Magnesium, look at the left side of your periodic table, is Mg, it is +2, always. Iodine is on the right side, it's always -1. The charges have to add to 0, so we're going to take 2 of those so that they add to 0. And then the name is remarkably like this, it's just magnesium. And the cation, the positive, usually just gets the name. There is an exception, sort of, but we'll get there. And then it's just iodine, so it's iodide. So let's jump to one of the exceptions. It won't take quite so long. Now, I would put a note. Iron 2 means this is the charge. Why would they have to tell you? They didn't tell you before. Go look at your ion chart, and there's more than one kind of iron. So if they don't tell you what type, it's cheating you. So they had to tell you, this is iron positive 2. Oh, iron. It's positive 2. I don't know it's Fe. Well, you'll look around the periodic table till you find it, or you can ask me or your neighbor or something. Sulfate, remember we said 8-ite stuff is on the back of the ion chart. So go find sulfate. It's SO4 minus 2. The charges add to 0, but they already do. It's already fixed. Quit fixing it. Mercury has an anciently associated name, and I don't remember why, but it's Hg for some reason. I know people think it should be like Mr or something, but it is not. Because it's from Latin, probably. And what does that mean? It means it's positive 2. That's what the Roman numeral here means. What's nitrate? Look on the back of the periodic table on the ion chart. Nitrate is NO3 minus 1. The charges add to 0, and those don't do it yet. So we're going to have 2 of that. Remember, if you're going to have 2 of a group, you need to put parentheses before you put the new number. Magnesium nitride. Magnesium on the left is positive 2. Ide, we said, means it's just that element. So that's just nitrogen. And nitrogen is in your minus 3 column. And remember, when I talked about how can 2 and 3 match, it's if you have 3 of the 2 things and 2 of the 3 things. And then you can have plus 6 and minus 6. So we'll have 3 of those and 2 of that. And then it's plus 6 and minus 6, and it adds to 0. So let's go down. We can't do all of them. Let's go down to here. We're going to give the formula and the name. So chromium plus 3. So chromium is a plus 3, huh? And sulfur. Look on your periodic table. Sulfur is a minus 2. Now this is like the reverse of this one. We have plus 3 and minus 2, but it's the same kind of idea. We need the charges to add to 0, so we'll have 2 of this and 3 of that kind of thing. But it'll reverse. So I have 2 of this and 3 of that instead of 3 and 2. Now I have plus 3 and plus 3. I have 2 of those, so that's plus 6. And 3 of that, so I have minus 2, minus 2, minus 2. So I have plus 6 total and minus 6 total. What's the name? Okay, here's the new thing. It's chromium. And what we're going to do is use this method back here. Remember we said the charge was the Roman numeral, so we're going to use the Roman numeral. Now, why do we know to do that? And so write this down. If this cation has more than one version, how would I know? I don't memorize these things right. But if you are wondering, go look at the back of your periodic table on the ion chart. It's alphabetical. You know it's a positive, so look on the left side. Is there more than one version of chromium? Yeah, it has multiple charges, doesn't it? It doesn't always have positive 3. So we're going to tell the people reading this that it's positive 3, and we're going to do that by this. Roman number 3 in parentheses. And then they will say, oh, you mean the positive 3 type. And then we said, if it's just sulfurs, it gets that ide. If it's just that one element, it gets ide. So sulfide. Whoops. Sulfide. Why did they have to say plus 1? Because on your ion chart, copper, that's copper by the way, has more than one charge. So first let's put the formula, I guess. Cu, and it's a plus 1. What's carbonate? Look on your ion chart. It's CO3 minus 2. The charges have to add to 0, and they don't yet, so we'll need 2 of that. So it's 2 of that. And 1 set of CO3. And people sometimes tell me, and we have 3 sets. No, I have 1 set of CO3. I mean, I guess you could put a 1 out there, but no one does. I mean, honestly, it's really riding around with your training wheels on in, you know, in 8th grade kind of thing if you put 1 out here. There's no need for it. It just looks weird. I mean, I guess you could, but it look weird. So let's not do that. What's the name? Well, this is copper. So we said the cation gets the name, except that we also said when there's more than one kind of it, more than one charge, we had to tell the people. So put that. And then for these groups, we'll just put the name. Just put the name, and it's right there, carbonate. And then some kid says, well, you put the name. You don't put the name. It's the name it has, right? Okay, but this is a group. It's 1 carbon and 3 oxygens all together as a group, and the groups just get their name. This is not a group because it's just sulfurs, but there are 3 of them, right? But it's just one element type, one type of atom. Now I know it's 3 times, but that doesn't count as a group that always appears together. It's not always S3. Could have been S2 another time. But carbonate is always 1 carbon and 3 oxygens, and it's always -2. So it gets its own name. How about cobalt? That's +2. Cobalt is +2, and on the back, hydroxide is OH -1. The charges have to add to 0, and they don't yet. So we're going to need 2 of that, and for groups, you got to put parentheses and the counting number of the groups outside. And then we said, we put the name of the cation, and is cobalt always +2? I don't know. Go look on your ion chart, and the answer is no, it's not always +2. So we will have to tell the people it's cobalt, that's the +2 kind, and then hydroxide, because that's the name of that group there. How about this one? That's a 4, by the way. That's a Roman 4. So nickel, that's a +4, and sulfate. Sulfate is in the back. Hit pause, go look it up. It's SO4 -2. The charges have to add to 0, and they don't yet. So what I need is more negative. So I'm going to do parentheses and 2 of that. And now I have +4 and -2 twice. That does add to 0. And we already had the name. That's why it just says give the formulas. How about this one? Vanadium is just V. I don't expect you to know that, but eventually you would find it on the periodic table. And this means it's +3. Oxide means it's just oxygens, even if you have 29 of them. So it's just oxygens. And on your periodic table, oxygen is -2. And the charges have to add to 0. And as we pointed out, how do you make 2 and 3 add up to 0? You have 2 of one and 3 of the other. Kind of swap them, don't you? So we will do 2 of this and 3 of that, and then we will have +6 and -6. How about, all right, one more. Tin. Now, tin has been known for a very long time. So its name also comes from the Latin, which is stannum. So the symbol is SN. Now it's +4, and bicarbonate is on your ion chart, and it's HCO3, and it's -1. The charges had to add to 0, so I will need 4 of that whole thing. That looks like the H has no leg. And when you need more than one of a group, you got to put it outside parentheses that you have to invent. You have to put the parentheses yourself.